Hi. So let us do one more control system concept, which is a Routh array. So using this Routh array, we can able to find out whether the system is stable or not. Exactly, we can identify how many number of poles are there lie to the right hand side of the S-plane and how many are there on the left hand side of the S-plane, which will ultimately tell you the stability of the system. So now this is the characteristic equation of a certain system. So we are supposed to write the Routh array for this. So for writing the Routh array, you start with the highest order of S, which is S power 4. You write the quotient of S power 4, which is 1 here, and of course the next element of this row is the alternate quotient, which is S square, which is 8 here, and it is 3. So it is 1, 8, 3. So this is of S power 4, S power 2, S power 0 quotients. Next it is S cube, it is 2, 4, 0. So first two rows of the Routh array are filled using the characteristic equation coefficients, so writing its alternate coefficients. Next is I should fill in for S square, which is nothing but 2 into 8 minus 4 into 1, that is this into this minus this into this divided by this, so divide by 2. So whatever is the answer that comes, so here in this case it is now 16 minus 4 divided by 2, so it's actually 6 now. So you're going to have this as 6, and the second element of this row is now this 2 into 3 minus 1 into 0 by 2, so it's actually 2 into 3 minus 1 into 0 by 2. In this case it's actually, because this will become 0, 2 and 2 will go off, and it is 3. And of course the next term is 0. This is of S square. Similarly, I should proceed to find S power 1 row, which happens to be this 6 into 4 minus 2 into 3 divided by 6, which happens to be, so now what is this? It's actually 6 into 4 minus 6 divided by 6. It's actually now 3. So this comes out to be 3. And then we have this 6 into 0 minus 2 into 0 by 0. So that is actually 0 only. So this is now 0 and this is 0. So this is S cube. Sorry, this is for S square, this is for S power 1. So next it is S power 0. For S power 0, what is this now? It is this into this minus this into this. It's actually 3 into 3 minus 6 into 0 by 3. Of course it is 0, 0, because 3 into 0 minus 6 into 0 by 3 happens to be 0. So now what is this? So this is 0, this 3 will go, you'll end up with 3. So if I rewrite this now, S power 4, S power cube, S square, so this is 1, 8, 3, 2, 4, 0. For clarity, I can write it as 6, 3, 0. S power 1 is 3, 0, 0, and S power 0 is 0, 3, 0, 0, 3, 0, 0, plus this again 0, 0. Now we have completed the Routh array. After completing the Routh array from highest power to the S power 0 coefficients, you look at the first column of the Routh array. So this is my Routh array. Look at the first column. All of them are positive. All of them are positive, because we know that this is the characteristic equation. It has got 4 closed loop poles. Now I want to see in this S plane, so this is my right hand side, this is my right hand side, this is my left hand side. So let me say this is on the left hand side. Let me put it as green because this happens to be the stable region. This is stable region, this is unstable region for the system to be unstable. Now I want to see where the poles are. Since there are no sign changes, so you don't have any closed loop poles here. All the 4 closed loop piles or the closed loop poles lie on the left hand side of the S-plane. So they are not neither on the imaginary axis. All the 4 lies here. All the 4 lies over here. So none of them are there onto the right hand side of the S-plane. So there are no sign changes in first column of Routh's array. Therefore all closed loop poles, that is all the 4 are on the left hand side of S-plane, so that system is stable because there is no sign change. If there is a sign change happens, so then those many number of poles will go to the right hand side of the S-plane. Let us see this problem. Okay, this is fairly simple. So if you solve 2, 3 Routh's array, so it will be, so it is S power 6, S power 5. So let me write it for this. It's actually 1, 2, 5. Just write this 1, 2, 5 and 20, and the next one is 3, 9, 12. So it is 3, 9, 12. It's not there, 0. Next you need to write it for S power 4, which is nothing but 3 into 2 minus 9 by 3, and it is, this is first one, it is 3 into 5 minus 1 into 12 by 3. Next is 3 into 20 minus 1 into 0 by 3. So this comes out to be, how much is this? So it is 6 minus 9. Okay, now it is minus 1. This is again S power 4, and this is now 15 minus 12. So the 15 minus 12 is 13. Okay, it's again now 1. This is now 1, and here it is 20. You can see now 1, 3. This is minus now. So I need to continue with S power 3. So for S power 3, let me write it. Minus 1 minus of 3 into 1 by minus 1. Next it is minus 1 into 12, minus 1 into 12, minus 1 into, this was minus 1 into 12, minus of 3 into 20 by minus 1. This is the second term. The third term is minus 1 into 0 minus, because here it's again 0 is there, minus 3 into 0 by minus 1. So what will be this? So this will be, so you have minus 9 minus of 3 divided by minus 1. So it's actually 12. So this is plus 12. This is what you have, minus 12 minus of 60 divided by minus 1 is 72. This is 72, and this is 0, 0. This is S3. Next is, let me do it for S power 4, sorry, S square. So for S square, what is because now it will be bit lengthy because you have S cube. So is it now, shall we do it directly here? Is it 12 into 1 minus of minus 1 into 72 divided by 12. So it's actually 7. This is 7, and then 12 into 20, because this will be 0 and this will be 12. Sorry, this will be 20. This is 20, 0, 0. Then it is s power 1. For s power 1 it is 7 into 72 minus of 12 into 20 divided by 7. So can you see it is 37.71, and this is now 0, 0, 0. Next it is s power 0. Is it not this into this minus this? Is it not 20? So this is the number. Of course, let us not rewrite. So what you have this as 1 here. The first element is 1, which is positive. This is positive. Here it is negative. Here it is positive. Here it is positive, positive. So now let us count the number of sign changes. Plus to plus, no sign change. Plus to minus, 1 sign change. Minus to plus, this is from minus to plus. Here it's again 1 more sign change, and then plus to plus, no, plus to plus, no, plus to plus, no. So there are 2 sign changes. 2 sign changes. So there are 2 times sign has changed from plus to minus and then from minus to plus. So out of 6 roots, so 2 lie to the right hand side of the display. So 2 are lying somewhere here. The remaining 4 are lying on the left hand side of the display. So this is 2 on right side, this is 4 on right side. Why it is 2 means there are 2 sign changes. The number of sign changes indicates how many are there to the right hand side of the S plane. So this is my S plane. So now out of 6, 2 are lying to right side, 4 are lying to left hand side. System is unstable. Why it's unstable? For a system having even one pole to the right hand side of the S plane, a bounded input will give you an unbounded output, because it will be e power plus x plus xt. So this xt depends on what is the pole position on the right hand side. So since the as t tends to infinity, this value going to be infinite. So you will end up with an unbounded output, which is called as an unstable system. So this characteristic equation, upon writing the Routh array, it's found that there are 2 sign changes happening on the first column of the Routh array, so that out of 6, 2 are there to the right hand side of the S plane. System is unstable. Okay, let us try out for this. Again, let me write. So this is s power 5, s power 4. Let me write the coefficients of alternate. So is it not 1? Okay, 8, 7. How about this? Is actually 4, 8, 4. 4, 8, 4. Let us write it for s cube, which is nothing but 4 into 8 minus 1 into 8 by 4, and this is 4 into 7 minus 1 into 4. This is like 4 into 7 minus 1 into 4 by 4, and then this is actually 0. So what is this now? So it's actually 4 into 8 minus 8 divided by 4 is 6. So this is now 6, and this is 4 into 7 minus 4 is 24. 24 by 4 is again now 6. It is 0. So it is 660. This is s cube. Let me write it for s3, because why I am writing is this is the simplified, okay, upon calculation. What is s power 2 now? Is it not 6 into 8 minus 4 into 6 divided by 6, and then it is 6 into 4 by this. Is it not 4 now? Is it 0? So then what is s square? Is s square is, what is that value? Is it not coming out to be 6 into 8 minus 4 into 6 divided by 6 is 4. This is now 4, 0. What is s power 1? So s power 1 happens to be, see now, s power 1 is 4 into 6 minus 6 into 4 by 4, then it is 0, 0. See now, s power 1 happens to be 0, 0, 0. So this is a special case. So now when you have something like this, so let me rewrite this. So when I rewrite, this is s power 5, s power 4, s power 3, s power 2. So is it not, so shall I write it as 1, 8, 7, 4, 8, 4, 6, 6, 0. Is it not 4, 4, 0? Then s power 1 is actually 0, 0, 0. When you have this 0, 0, so this indicates that, so this is a special case saying that there is an auxiliary equation corresponding to this. So we will end up with an auxiliary equation. So there is an auxiliary equation which I call it as a of x or a of s. A of s is nothing but this auxiliary equation. A of s is a row above this, a row above where the complete zeros are there, is 4s square plus 4 equal to 0 is my auxiliary equation. So once you have the auxiliary equation, take the derivative of this, differentiate this with respect to s. It is d of as by ds will become 8s is equal to 0. So this is the derivative of the auxiliary equation with respect to s. So now I will discard this 0, 0, 0 and replace it by the quotient of this auxiliary equation, which is nothing but 8, 0, 0. So now, since I had it as 0, 0, 0, I could not complete my auxiliary equation, because the Routh array, as soon as you end up with 0, 0, 0, don't proceed. So if all the elements of a row become 0, 0, 0, you are not asked to proceed further. So once you have it as 0, 0, 0, stop there, write the auxiliary equation which is a row above that, which is this. To fill this 0, 0, 0 by something else, you differentiate this auxiliary equation with respect to s, you got this, and using this 8s equal to 0, fill this. So 8s is equal to 0, is it not 8 here and then 0, 0 here? Now you complete the other one. So is it not 8 into 4 minus 4 into 0 by 8 and 0, 0? Is it not now 4? Is this not reducing to 4 now? Now what is the first column of the Routh array now? Upon modifying this with so and so, is it not 1, 4, 6, 8? This is 1, 4, 6, another 4 is there, another 8 is there, another 4 is there. So this is the first column of the Routh array. So what does this first column of the Routh array say? Since there is no sign change, this indicates no closed loop poles. It's not loop. No closed loop poles lie to the right hand side of the S-plane. Out of 5, none are there to the right hand side of the S-plane. Shall I say that all the 5 lie to the left hand side of the S-plane? No. So in the previous cases, what we said was, when there is no sign change in the first case, out of 4, since there are no sign changes, we said all 4 lie to the left hand side of the S-plane. Because there is no sign change, none lie to the right hand side. Now here I cannot say that all of them are lying to the left hand side of the S-plane, which is 5 in number. Why I can't say is because I have completed this Routh's array by doing one small change. So there was a 0 0 0 came, I just completed this after taking the auxiliary equation derivative and then proceeded. In such case, what does this will indicate is this will certainly say no poles to the right hand side of the S-plane, because there is no sign change, because all of them are plus, but where are those remaining, where are the all 5 poles? Because this auxiliary equation is a part of my main equation. So can I able to know what are the roots of this auxiliary equation? Suppose if I equate 4s square plus 4 to 0, shall I write it as s square is equal to minus 4 by 4? Shall I say s is equal to under root of minus 1? So shall I say this, what is this? Actually this has got now 2 roots. So what is this under root of minus 1? Is it not plus or minus j1? Now out of 5 roots, the auxiliary equation says that it has got roots at plus or minus j1. So here you have one at plus j1, other is at minus j1. So out of 5, 2 roots which is decided by the auxiliary equation is having closed loop poles on the imaginary axis. Where about the remaining 3? Remaining 3 will be there on the right hand, on the left hand side. So left hand side you have 3 poles. On the imaginary axis 2, none to the right. So here there are no closed loop poles on the right hand side. 3 are on the left hand side, 2 are on the imaginary axis. So now what is the stability? Stability is, since you have poles on the imaginary axis, system is oscillatory, or say it as critically stable. By just seeing this, I can't say system is stable, but what is the indication of this? No poles to the right hand side. Does all of them lie to the left hand side? No, in this case, because I have completed this Routh's array by taking the derivative of the auxiliary equation, because it has resulted in auxiliary equation because of this 0 0 0. So when you end up with this 0 as 0 0 0, you wrote the auxiliary equation and you completed the array by taking its derivative. So now whenever an auxiliary equation comes, before deciding what is the stability, you have to see where are the roots of auxiliary equation. If the auxiliary equation roots are on the imaginary axis, then you have to say system is oscillatory. System is now oscillatory, or it is critically stable. System is not stable. It is called as oscillatory or critically stable, or you can call it as marginally stable. These are the 3 ways of defining it. One is oscillatory, system is oscillatory, system is critically stable, or the system is marginally stable. You can try out for this. You can just give a try. Again, this is actually 18s. So give a try and try to complete the Routh's array. If you have an auxiliary equation, take its when do you end up with auxiliary equation? When the complete row becomes 0 0 0. And you can see to write the auxiliary equation, you have to take a row above this, which is 4s square plus 4. You have to take the alternate coefficients, alternate powers of s. If it is a square, you have to leave out s. So that's why this is s power 0. So that's why this is 4s square plus 4. So just give a try to this. We will see in the next video. Thank you.